Today's topic polarization. Now, when we say that particles oscillate depending on the direction of waves, but when you're trying to waves that travel in radiation, like for example, this is the source. Light comes out of the wave, comes out of the source radially outward. Same goes for the sound, the compressions and rarefactions, they come away from the source and they go radially. Now, let's pick up one of the lines. And we say that the particles of the medium are oscillating perpendicular to the direction energy. How would you put it in reality over here? How would you make this out of this? So if this is the direction of travel of energy, this is energy. We say that the particles are vibrating perpendicular. मतलब क्या है इस बात का perpendicular? अब perpendicular का आप कहेंगे कि this is perpendicular. But ऐसे ही perpendicular क्यों नहीं हो सकता? Why it cannot be perpendicular like this? ऐसे भी तो हो सकता है particle is perpendicular. Particle can oscillate perpendicular like this. Or it can oscillate in any direction. All these directions will be perpendicular. Actually, you can actually make a disk over here. Listen. हम 3D को अंडरस्टैंड करने की कोशिश कर रहे हैं on a two-dimensional board. It might make less sense, but let me give you an example that will make more sense. This is the floor of your room. And this is you standing over here. Okay. Now, are you perpendicular to the floor overall? If you are standing, are you perpendicular on the floor? Answer is yes. Now, tell me how many different lines we can make on the floor at the same time. And technically, with any line on the floor, you are perpendicular. ये फ्लोर में मैंने जितनी भी लाइंस लगाई हैं, don't you think you are at 90 degree to all of these lines at the same time? So, if energy is going along the direction, this one, this is propagation of energy. And this is happening only in transverse waves. Now, when transverse waves are set in three-dimensional medium, and we said the particles are oscillating perpendicular to the direction of propagation of energy, practically speaking, particles can be oscillating in any direction. All those directions are simultaneously perpendicular to the direction of propagation of energy. So, आज हम क्या कर रहे हैं? इसका मतलब है जो पार्टिकल्स हैं वो ऑसिलेट कर रहे हैं same grade. In direction, it will not grade. For example, if all particles are oscillating in the same plane, all particles are oscillating in the same plane. All these particles are in same plane. Now, how is this one a different transverse wave than this one? Now, upper one is a non-polarized transverse wave. And this one is polarized transverse wave. So what is the difference between polarized transverse wave and non-polarized transverse wave? All particles are perpendicular, but in same plane. Hence, wave is polarized. And upper one, non-polarized, particles oscillate perpendicular, but not in same plane. Okay. In polarized, they all oscillate in the same plane. In non-polarized, they do not. How to polarize a transverse wave? Polarizer. What is a polarizer? No. There are very small grooves over here. These are very small grooves, and light has to, or wave has to pass through this one. So this is a polarizer. Polarizer. Rigid material. Rigid material means that it is not allowing the wave to only pass through these small openings. wave then pass through. So this is important. So pay attention. Now, if waves are coming which are non-polarized, for example, like this, and particles are perpendicular, particles तो ऐसे भी perpendicular हो सकते हैं. They can be perpendicular like this. And there are so many ways they can be perpendicular, but not parallel to one another. Talking about being perpendicular in 3D. Okay. So actually, the particles can be anywhere like this, this, or this, or this, or can be vibrating in all these possibilities. Okay. So this is a non-polarized wave. So what will happen when wave will pass through this? Here are woven particles which are oscillating perpendicular to the wave. They will make through it. This one. So ये वाले particles बाहर आ सकते हैं. Polarized wave. Only particle along the direction of polarizer orientation will make it through. तो होगा ये कि the particles that are along the direction or the oscillations that are along the direction of the polarizer will make it through. The rest of the waves will get absorbed. If this is a polarizer, a particle which is operating like this can pass through. A particle which is operating the only particles that are in the same direction as the polarizer will be able to make it. So this one will go, this one will go, this one cannot go. What there is one. Hello. Okay. So a wave is a transverse wave if it can be polarized. All electromagnetic waves can be polarized, hence they are all transverse in nature. So I have used a new term, intensity of wave. What is intensity? Intensity of wave. Any intensity means power dissipated or power provided per unit area. If somebody asks you what is intensity, you can say it is power per unit area. So intensity equals to power over area. Unit for power is watts. Unit for area is meter square. What should be the unit for intensity? Watt meter square. So intensity's unit will be watt per meter square. तो इंटेंसिटी की यूनिट वॉट पर मीटर स्क्वायर होती है, ये हमें बताती है कि हाउ मच पावर इज अवेलेबल ऑन ए सर्टेन एरिया. Now if this is a source, let's say this is a lamp. Now lamp produces light, and I hope you understand that the light that is produced by the lamp will expand radially outward. Okay, so here is the distance, how distance increases from the source. Now if you see, what happens to area if we double the distance? Look, if this distance is r, as this distance is 2r, there is same power that is available here, and now same power is distributed in a bigger area that has area 4 times more. If you double the distance, if you double all the dimensions, area will become 4 times. If this area is A, this area will be 4A, and this area will be 9A. If this distance is 3r. So here's the thing. Intensity is inversely proportional to distance square, where I is intensity and r is distance from the source. I is intensity and r is radial distance from source. Okay, this thing is also known as inverse square law. This kind of mathematical relationship has a name. This is called inverse square law. If you double the distance, intensity reduces by 4 times, because intensity is inversely proportional to not r, but r square. So if you double the distance, actually you're making making area increase by 4 times. Okay, so one more thing, intensity is directly proportional to amplitude square. I is intensity and A is amplitude of oscillation. So here we have two very commonly used relationships. We don't have a formula right now, but this is the relationship that we know, that if we increase the amplitude, the intensity will be directly proportional to square times of amplitude. So if we double the amplitude, intensity will increase to 4 times. Similarly, if we double the distance from the source, if we go away from the source, intensity should decrease. And there is also a inverse square law relationship over there. So if you double the distance, intensity will decrease by 4 times. So when you mix these two things together, you can also find out A is inversely proportional to R. So if you double the distance, amplitude should decrease to half. So here we go. This is all we need to know about polarization and intensity. Okay. In the next lesson, we will be doing phase of an angle, a phase of a wave, and then we will go into interferences and diffraction. This will be the next lesson. We will start from this point tomorrow. Thank you very much.
Okay, sir.